Hello and welcome to Rewild Long Island webinar, Green Roof Features and Benefits by Dan Cook from CLINTON+RIES Landscape Architects. Green roofs offer many benefits to our ecosystem in addition to providing beautiful alternatives to traditional asphalt. Fortunately, they are growing in popularity in new commercial and mixed-use building construction. Learn how they benefit our ecosystem as well as design and installation considerations in this webinar. Dan Cook, ASLA, is an associate at CLINTON+RIES Landscape Architects. He oversees the firm's seasonal rotations division, coordinating large-scale decorative plantings quarterly. A Long Island native with deep appreciation for the outdoors, Dan is passionate about creating and maintaining healthy ecosystems through thoughtful garden design. He earned his degree from SUNY College of Environmental Science and Forestry before moving to Washington, D.C. to pursue his career in landscape architecture. A little bit about CLINTON+RIES Landscape Architects. It's a woman-owned firm led by Kate Rees and certified by NWOBC, has built a 25-year legacy blending landscape architecture, art, and horticultural design, guided by stewardship to create innovative, sustainable landscapes that harmonize with natural systems and client needs. And with that, I give the floor to Dan.
Great. All right. Well, I wanted to thank everyone at Rewild Long Island for having us, and all of you for joining in and listening. So yeah, we're going to talk about green roofs today, and we're going to analyze it through one of our projects that we worked on about 5, 6, well, I guess closer to 8 years ago. It's a building called Chapman Stables in Washington, D.C. The building was in active design when I first joined the firm. So I kind of was on the tail end of the design side and then worked a lot through construction administration as the building was being built. And we've been fortunate enough to stay engaged with the building by working with the landscape subcommittee from the residents, as well as working with maintenance staff and the landscape contractor that maintains the property. And even this past summer, we held a cultural landscape foundation tour of the building. So it's really nice to remain involved and be able to see it kind of as it evolves from installation and through through people living in it and enjoying it and now. So this is our quick agenda here. We'll start off, what is a green roof? We'll talk about the benefits of green roofs, types of green roofs, talk about design and how all these elements come together, and then lastly, installation. So what is a green roof? The EPA gives this incredibly vague definition. A green roof or rooftop garden is a vegetative layer grown on a rooftop. So to me, that sounds like it could be anything. You have a little dirt pile, some weeds coming up, bam, you got yourself a green roof. And I think some of you who said you hadn't seen green roofs are maybe rethinking that now. But to me, the most important part of this definition is the vegetative layer portion. And when you think about building systems and how they get designed, the electric, that's a layer. Plumbing is a layer, framing a layer, insulation a layer. And so the vegetative layer for a green roof, to me, indicates that it's purposeful, it's designed, and it's part of this larger system or building fabric, that's allowing the building to function. And then New York Parks and Gov, they kind of elaborate on this. So, we're talking layers. A green roof is a thin layer of vegetation installed on traditional flat or pitched roof. And then they go on to list some basic components: waterproofing, root barrier, water retention and drainage, growing medium, and a plant. So with that in mind, what is the benefit of these green roofs? What what is this vegetative layer providing in a building where seemingly green roofs haven't existed for a very long time? And so the first thing is they reduce urban heat island, which is massively important. So when you think of a traditional roof assembly, that is typically an asphalt layer, and asphalt is dark, it heats up and it holds heat, and it slowly releases that heat overnight, which over time increases the temperature in cities where there's more impervious surface that's heating up and holding this heat. So plants, they're not holding heat like an asphalt or concrete is. They're letting heat, they're reflecting it, it's bouncing off, they're absorbing it. And so it contributes, they say up to almost 57 degrees can be reduced by planting a green roof. Whereas if you were standing on that roof in a traditional asphalt assembly, it would be 57 degrees hotter. And so when you are eliminating all this heat, naturally, you're also decreasing the building energy needs. So your roof, it's not absorbing all that heat and holding it. The plants are taking care of that. You don't need to cool your building as much. So they estimate, and they being the EPA, estimate that buildings can achieve almost a 57-cent per yard reduction in cooling needs over the course of a day, which when you add up square footage over the course of a building or a block, you're really starting to reduce significantly the amount of energy being pulled from the grid. Another really important thing they do is they absorb stormwater. So again, thinking about a traditional roof assembly, when it rains, almost 100% of that water is ending up in a drain, down a downspout, and into the storm system. With a green roof, there's plants, they are catching and absorbing water. The soil, the growing media is holding water. There are layers to a green roof for water retention that help capture water and hold it for the plants to use at a later time, and inevitably reduce the overall surge during storm events into the storm system. They improve air quality. We all know you buy a snake plant or a ZZ plant or a pothos, and they say to put it in your bedroom at night. They are working the graveyard shift. They're taking all that carbon dioxide, they're turning it into oxygen, they're improving your sleep. It's the same quality or same idea, just on a much larger scale. So now you're taking all these plants, and all night they are just purifying the air, and can significantly improve the air quality of that rooftop. And then the last thing is increased habitat and biodiversity. And it seems silly, like a little rooftop plot, how significant or impactful can it be? But it's actually studied that they can improve specifically biodiversity of insects and subsequently birds, by 15 to 20%. And the birds and insects will seek that rooftop out over others for obvious reasons. And I'm sure some of you or all of you are familiar with the homegrown national park movement, just the idea that if we all change a little bit or all of our front yard into native plants, then your whole property and a block can start to turn into a national park and really change the ethos of this current manicured lawns that we have. So that same kind of concept can apply to building rooftops. And so what kind of types of green roofs are there? Because there's several. And there's two distinct types that are defined by the soil depth. And so those are extensive soil green roofs, which have a depth of less than 6 inches. And then there's intensive green roofs, which have a soil or growing media depth of more than 6 inches. And this picture is kind of nice. So you can see in the background, there's a lower portion of the building, and it has much lower growing sedum mats on them, and we'll get into what sedum mats are, but you can see it's not even the height of a window. It's just a little thin growing media. And then where we have a little bit more room on this upper portion of the rooftop, this is closer to the amenity terrace. There's a deeper soil profile. We can get some bigger perennial plants in there to grow and fill in and look beautiful. And then beyond those two, there's tray systems versus layered systems. And these are kind of methodologies for how those extensive or intensive green roofs are installed. So a tray system, this is a detail from this Chapman Stables project where we had a transition from a tray system into a layered system. Tray system is exactly what it sounds. It's a rectangular or square gridded tray that you then assemble and layer each of the different elements of a green roof on. And a layered system is kind of, you place it layer by layer right on top of this insulation, root barrier protection, waterproofing layer. So you kind of build it up, and you can see from our detail here, this checkerboard hatch pattern, that's your insulation, root barrier, waterproofing. And then the layered system starts to build up. We have our filtration, drainage layer, our geotextile layer, water retention layer, and then just soil. Whereas in the tray system, you can see the drawing is a physical tray that we then fill with ballast and growing media and all the plants. All right, so green roof design. How do all these layers come together to create this? And before we get into that, so this is a plan rendering of the Chapman Stables building, and it'll help, I think, identifying these areas will help understand the next coming few details we put together here. So this thick dark line is the face of building. This kind of grayed out portion is streetscape planting and at grade entrances. So this bottom portion of the building was a existing abandoned building that was on the National Registry for Historic Places. So that portion of the building was renovated, and then this upper portion that connects with this little corridor here, that's an entirely new building that was added. So you can see all of this colored planting, that's all green roof surrounding this existing portion of the building. Here's the amenity terrace and some rooftop penthouse level gardens, mechanical roof, and then again gardens on these are little terraces for the residents. They can each individually have one for their units there. In the center of these is what we call the central courtyard, and it's actually slightly below grade, but it's built on top of the parking garage for the building. So there's a parking garage below both of these buildings for residents to park in. And so this technically is also a green roof, and we'll talk about sort of the differences in the assemblies of this commons courtyard, central courtyard place, as well as the rooftop here. So just a quick diagram. As you can see, there's intensive green roof. So we're talking more than 6 inches of soil that surrounds the amenity terrace and these areas for the residents for their gardens. There's a small pocket here of intensive green roof, and then the central courtyard is intensive green roof. And then this mechanical rooftop and this other portion of smaller balconies that overlook the central courtyard, and this series of mechanical roofs for the existing building, those are all extensive green roofs, so less than 6 inches. And in this case, we were dealing with a 4-inch growing media on these buildings. And that was set by the architect. So based on where the finished floor elevation of these penthouse apartments were and the parapet wall, we only had about a 4-inch depth to work with. So that makes that extensive. And then, you know, the other areas we had a little bit more leeway. We can get some deeper soil depth in there for our perennials. And so here's a detail of intensive green roofs from this project. So you can see, we'll touch on all these individual layers in a second, but everything layers up, and this is a layered portion of this green roof. So this is on the left here, the parapet wall, and you can see each of these layers wrap up the side, and we call it creating the bathtub, because it helps hold water and prevent that water from getting down into the insulation and onto the structural slab of the building and the roof. Here, immediately next to the green roof is a pedestal paving system. So this is a porcelain paver that's like 3/4 of an inch thick. And at each of the corners, there's these pedestal systems that you set the paver on top of. And so immediately adjacent that, there's a metal aluminum edge restraint, and that helps hold the soil in on the plant side and prevents soil from washing out underneath the pavers, where there's all sorts of like conduit and allowing any water that isn't absorbed by the green roof to make its way out to the roof drain. And so this is a picture of an intensive green roof from Chapman Stables, from the project. So you can see here, if I go back, on top of the growing media, there's all these little sedums in our sedum tile. And then there is these larger landscape plugs that are installed amongst the sedum. And so you have these perennials sticking out, coming through this larger mesh of lower growing sedum. And that's a installation method. We'll touch on, there's a couple different ones, but we really like to use it. We've had a lot of success with it. And it helps keep the green roof covered from day one. As we all know, you go out and you buy a little 4-inch container, you got to wait, you know, a couple months for that plant to fully realize its size. And sometimes you're looking at a big bare patch of mulch. So having those sedum mats cover this area really allows for it to remain green from the beginning, and then it allows all the perennials to fill in over time. So these are a couple details from that central courtyard. And I wanted to just show these because, so you can see here, this is the top of the structural slab below. So below this is a parking garage, and that builds up. So this is soil, and then our trees with our guy wires to make sure that they stay in place and can root in. And you just clip those at the soil once, you know, a year or two passes and they're ready. And then you can see here for the shrubs, one of the big things we deal with when designing and speccing green roofs is their weight. And we'll touch on that when we talk about growing media and soil. But kind of a trick to get around that is to identify areas where you might not have really deep rooted planting, and you can use a geofoam and help build up the elevation so that it's super light. You have just the right amount of soil you need based on the plants you've selected. And it helps, you know, the structural engineer, it helps the architect, and it keeps us able to plant it over time. And so this is a picture from that central courtyard. So you can see, you know, we have trees, we have some shrubs in the background. It looks like this liatris is about to bloom. So we got some maybe threadleaf coreopsis, and then some on the right here, some euchra. So, you know, it just gives a lot of room for larger plants to fill in and grow and be happy. And then this is a extensive green roof. So this is a 4-inch depth here. So you can see all the same layers, and then the green roof mat here. And then how that feels much different than, say, this image where you have all these perennials coming up and looking in, filling in beautifully. And then these just remain as these little sedum succulent gardens, where we don't have that rooting volume depth based on the design of the building. So it really allows us to kind of jam green roofs in wherever we have, roughly 4 inches. And, we talked about all the benefits. It really can go a long way. So yeah, green roof design, analyzing each of these layers. And so I brought this New York Gov Parks definition back, and waterproofing, root barrier, water retention, drainage, growing media, those are what they're defining as elements that make each of these systems actually a green roof. And so the first one is waterproofing, and that is typically specified by the architect, and it's tied to the roof system assembly that they want to use. There's a couple different ones, and that it's usually that way because as the roof is constructed, it's constructed on a warranty. So when you select one type of roof assembly, it ties you to what, brand of green roof, a type of paver, a type of root protection, growing media, yada, yada. And so when the architect picks what roof assembly they want to use, it triggers to us what type of green roof assembly we want to then move forward with based on, what they're using. So, we saw in those details, after that waterproofing layer is a root barrier, and that's just an LDPE or high density polyethylene product. It rolls out on a mat like you can see here, right on top of that waterproofing layer. And it's twofold. It obviously helps prevent roots from going down, but it also is just an added layer to prevent water from making it down into, and being in contact with the waterproofing. This way, you're just keeping yourself as many checks. Ultimately, with buildings, you want to keep water outside of them. And then there's water retention and drainage. So drainage board is a product that you can see here. It has all these little corrugated elements, and it's meant to both hold water and help facilitate the movement of water to a roof drain. And those seem counterintuitive, but when these rooftops are designed and constructed, unlike on a ground plane where a sidewalk has a pitch or a plaza has a pitch, and you pitch that plaza towards where your drainage is, your roof plane wants to be flat. And so the roof is flat, and the drainage board, what it does is in all these little cups, it holds water below the green roof, and it allows that water to be absorbed in the future by the green roof. But it also, water that isn't trapped, it has these grooves you can see from these blue arrows that it allows water to trickle through, and the material of it uses capillary action to pull water along, even on a flat surface, towards a roof drain. And then water retention matting is something that's not always added, but it's usually added right above the drainage board. And then it allows the water retention matting will hold the water. Whatever excess, once it hits capacity, will then drip down into the drainage board. So it's just kind of an added measure of protection below this green roof system. And so if you're using a tray system like we talked about, right after the water retention matting, the tray just sits right on top of that. If you're doing a layered system, that's when you then start to build up your growing media. So you can see here, this is a photo of the building right after they installed all the soil. And it's pretty neat. If you've never seen it, they bring the soil in on these huge trucks that have a giant pump, and they pump the soil up however many stories right onto the roof. It's pretty pretty wild to see. But so the typical composition of your growing medium is an inorganic material like porous stone, a lava, or a lava rock, and that part of that is to help reduce weight. Soil is very heavy. Then there's an organic material like compost or leaf compost, and that is to provide nutrients for the plants. And then there's sand added for structural and textural qualities. For green roof systems, there are a lot of kind of branded media options now. So Roof Light is one. American Hydrotech extensive or intensive green roof is another. Green Roof Solutions is a third. There's probably a dozen more. These are three we've used in the past. And it's just slightly varying types of lava rock or porous stone, or some use pine fines versus hardwood compost. So again, that kind of depends on the plants you want to pick, which of these products you would use. And again, it also sometimes ties into that warranty. So for example, American Hydrotech, they offer a full soup to nuts roofing system. So it's areas that are not green roof. They're finished in this way. They use Hanover pavers and Columbia green roof products, and those all go together. And so when you see an architect specing an American Hydrotech roofing assembly, we know like, okay, we should start looking at Hanover pavers, and we want to use this Columbia green roof assembly. And that kind of helps guide us in the initial design phases. And then in other areas, like in the central courtyard here, sometimes on amenity terraces as well, we will specify a custom blend for larger plant bed or built-in planters. So that's anything that's probably exceeding, I'll call it 15 inches in height, anywhere from 15 to 42 inches if we're trying to put trees or shrubs. And that spec is usually a quarter volume of compost, a quarter volume of organic composted pine fines, and then half volume of furnished sandy loam topsoil. So that is, we have a soil spec for topsoil that we use in new at-grade conditions for some of these buildings. So we're taking by volume, half of that specified soil, and then we're basically adding some compost and pine fines to help lighten it up and put it in some of these larger custom designed planters. And so before we hop into plants, so there's two specific ways that you can actually plant a green roof. And I'm just going to poke back to this detail here. So there's these sedum tile, which are functionally a sod mat, but with all these little sedums grown on it, and they get rolled out on top of the growing media. And like I said, they're just green right from the jump. And so after that, what we like to do is come in and we take these landscape plugs and we can plant them amongst the green roof. You can also seed, so you can do seeded displays on top of the sedum mats as well. We have done both there, and the benefit for using like seed is you get this really organic kind of display for the planting. Same idea as if you were to seed in a meadow, you get really dense planting. Everything's coming in right next to each other. They're competing and filling in, and you get this really beautiful patina that kind of is designed by ecology, which is really nice. And we like to use that on our like mechanical roofs, or if there's a portion of the green roof that is outside of the amenity terrace that the residents can't get to, we'll do sort of like a wild mix of seed, and it looks really beautiful. But then if there's any areas that are right up next to the amenity terrace and we want it to feel kind of more like a cultivated garden, that's where the benefit of being able to use these landscape plugs is. You can really get cute with how you lay the plants out. You can do nice big drifts, if you want to do that. So it just gives you a couple options on how that physically gets planted. And so obviously for this project, we used landscape plugs. And so on the rooftop, this is the plant list of for anything on the rooftop in the intensive green roofs we have designed there. I wanted to just highlight a couple of the ones that we've observed that have just done so amazing. And also, you know, we love them in in at grade and all other types of installations. So Accolea Moonshine, which is a hybrid yarrow, really beautiful yellow flower, long blooming. We Coreopsis Zagreb, threadleaf Coreopsis, that just does so well in the heat and kind of the rough condition of a green roof. Same with Liatris, as well as the Muhlenbergia, which is just a phenomenal like fall champion with its beautiful pink seed heads. The Panicum, we actually had to come back in at the request of the landscape subcommittee and like thin some of the Panicum out. It was really, really happy up on the roof. A couple types of Rudbeckia, and you know, last but definitely not least, some Tara, Sporobolus, prairie drop seed. And if you're starting to pick up, a lot of the plants that are super successful on green roofs are plants that are successful in meadow conditions. So, you know, our native meadows are traditionally in areas with poor soil quality, no shade, you know, infrequent watering, and believe it or not, that is the exact condition of a roof. So they really bode themselves well to this condition. And then in the central courtyard, so again, there's buildings on really four sides. So, you know, we have a more shade tolerant approach here. But again, just wanted to highlight a few of the ones that we've really seen take off and grow. And two of them are actually trees, which is surprising. So the Betula nigra Durahit, phenomenal cultivar of river birch, holds up to like almost any condition. It's basically the Liripe of trees. Cladastris kentuckia, Hall of Fame native, love yellow wood, beautiful flowers, phenomenal fall color. It has great form. When you see it in the winter, and its branches are just really architectural and beautiful. Hamamelis ex intermedia Arnold Promise, another favorite that we have in the office, as well as the Hamamelis vernalis. Actea simplex, Hillside Black Beauty, this Baneberry, really just unique leaf color, and obviously big, massive white flowers. Asclepias tuberosa, Carex Everillo. This is a favorite of mine. I'd really love to use it in planted containers. It just has a beautiful habit, and the blades are really thin, so it texturally has a really amazing quality, and the color is really, it's just such a rich chartreuse. It's hard to find in other plant material. And then four natives to round it out, the Eragrostis, similar to Muhlenbergia, but a summer bloomer. Gallardia, great for rooftops when you're trying to preserve views but want to have flowers, low growing, just kind of creeps, loves the desert type hot ecosystem up there. Euchra, this is in more shady parts of this central courtyard, and then the Monarda. And so installation, you can see this photo is on the amenity terrace of the building. So we're looking out, and this is just roof, structural slab. This is what it would look like if it didn't have nice pavers or planting on it. That's asphalt. This is a future roof drain below the pedestal pavers we have there. And then you can see on the left here, this is that root barrier that's going down. And then in our layered portion of the system, we start to wrap some of the parapet wall and adjacent elements with our drainage board here. And then ultimately the soil gets piped up and the plants arrive and they get laid out, and it looks pretty uninspiring on day one with all these little plugs getting jammed in, but as you'll see, it fills in quite beautifully. And then yeah, so you can see here, this is another corner of the amenity terrace, and then this is looking back. There's a matching image of here for after it's planted that we'll stumble upon. And then in the central courtyard, so I mentioned this earlier, I wanted to talk about this and compare the two. So you can see here, this is underneath these cranes, that's the top of the parking garage roof. So we have all this room for soil media, but like I said, soil's very heavy. So this is where, the architect comes in and they talk to us, and then we get in a meeting with the structural engineer, and the structural engineer says, guys, this is too much soil. You just have too much. And so we need to get creative with how, we build this up and maintain soil depth in certain areas, but also achieve what the design weighted load for that rooftop is. So you can see from the structural slab, we have these big kind of arching knife's edge core 10 wall in the center. That's kind of like a feature wall. So this is the core 10 wall being framed up straight from the structural slab, and it looks so funny just kind of floating when you get to the the final as completed images. But after that, we have all this layer of foam that gets put in to help build up in a lightweight way where some of these where these plant beds are. And even here, this is a walkway here. So there eventually will be paving on top of where this guy is standing. And then in some of these other areas, there's plant bed. And then on top of that geofoam, that's where we come in again, our root protection and drainage layer. And then, same day, soil comes in, it gets piped in, and everything gets laid out. Here, you can see by the tape here, there's a couple stairs that lead down here. So those were precast stairs. So we were waiting on the precast stairs to arrive. So this remained a geofoam and wood ramp for the contractors. They were not too happy about that, carrying plants up and down that, but they work hard like the rest of us, and we got it planted and laid out. And so you can see from above all the different areas, the trees nice and small, shrubs mixed in there as well. And then yeah, the results. So this is that amenity terrace. We're looking southwest here. So the Capitol building is actually kind of right behind these larger buildings here. And you can see that Rudbeckia just in its glory, so happy up on this roof. People out here using the amenity terrace. One of the things I really love about this design is we worked really hard with the architect to detail how this glass parapet rail connected down to structural and how it sits within the planting. So the garden, you can really engage with the plants from all these spaces. So this is looking the other way. You can see Washington Monument in the back there. So this is that same view sort of what this view is. So you can see after it's just planted, how everything is nice and small, little landscape plugs. And then it, over the course of a year, it really fills in and looks just beautiful. And, I wish I lived in that penthouse right there, maybe one day. And then, yeah, this is looking from the grill area. So over here, these are some penthouse units. Again, we have that's our extensive green roof. So just the little sedums. And then in the central courtyard. So this is, you can kind of make it out that 410 wall, and we have some salvia coming up in here. The yellow woods, birch in the back. And then again, so you can see this is that paving, which below it is geofoam, and there's some residential units that have these sunken courtyards, within this central courtyard space. Yeah, so that is that's the chat, and these are some sources. I'm happy to send this document around if anyone is interested in it. And yeah, just thank you again. I'm very appreciative, so thank you. And if there's any questions, be happy to chat.
Yes, thank you, Dan. Thank you so much.
Yeah.
That is wonderful transformation indeed. Yeah, yeah. I would also like to live in one of those penthouses. Impressive. Yeah, yep, that looks amazing. And I do have some questions in the chat. Richard wants to know, would cedar mat restrict the perennial from reseeding?
No, we haven't experienced that. Like perennial plants are just way more hardy and vigorous than sedum. So we have actually, like I mentioned with the panicum, that was just self-seeding like too well. It was doing too well. And same at some areas with the Rudbeckia. Those were just so happy, and they were out competing other species. So we had to work with the landscape subcommittee of the building, and we actually transplanted a bunch of it to other portions of the roof. Some people, they were like, "Oh, I'd love that next to my terrace," and we would move it there or move it around, and this way to allow some of the other plants to establish. But no, they certainly can reseed.
Yeah, Rudbeckia, they are so, they
Yeah,
take over. They take
yeah.
over your space. Then we have a question. Is there a reason for, no, there is one from Gloria. Once the green roof is installed, what is the maintenance like? How does it compare to an in-ground garden?
It's really no different. There's your spring startup, where you go back and you cut all your grasses back and clean up any debris or leaf matter that might have accumulated. A lot of these buildings, this one had irrigation system installed in it, to ensure the longevity of these plants. But you can achieve credits for like LEED or other organizations by having like a temporary irrigation system where you basically just set up an irrigation system for establishment. And once the plants are established, you can come in and take that irrigation system off. That works really well in like the seeded meadow portions of these green roofs. But yeah, no, it's usually handled by the same landscape maintenance team on a lot of these commercial buildings. And so they just kind of incorporate it into their spring startup, their fall cleanup. And then beyond that, it's, deadheading and just making sure the garden portions are looking great for the residents.
Thank you. And then the next question is there a reason for the black pavers?
Um, where would the black pavers be? Yeah, let me see. I'm not sure.
The walkway, I think it's a question from Duong. She says the walkway.
In the walkway, there's oh, on the amenity terrace there. Yeah, those are like a porcelain paver, and they mimic like a darker bluestone. So it was largely an aesthetic choice. And from a materiality standpoint, porcelain doesn't heat up as much as concrete, so that it's also a thinner profile. So it was largely an aesthetic choice on the amenity terrace for why those were selected.
Thank you. And then Heather says, thank you very much for the info. I enjoyed it. And then we have Tara saying, very interesting webinar. Thank you. And I have another question from Duong, which is, how would the weight distribution work out as the plant grows? And how long do you need to water the roof garden?
Yeah, so a lot of the times when we're designing these, we're coordinating all of this information with structural engineers who are on the project. So they have models that they can track to understand, like, if a tree puts on 2 caliper inches over 5 years, or whatever metric, that they can basically track how much weight the tree will accumulate over time. And it's typically less than if, for example, we do a lot of office green roof gardens. So usually an office will come in and they'll say, like, we want to have a 250 event space, like 250 person event on this rooftop, and the structural engineer will design it to this max load for a ton of people, and usually the handful of trees are well below that as designed weight. So normally it is tracked, but normally it's sort of negligible based on the amount of weight that the building is designed to hold. And then for watering, so you do need to water a little bit more than, especially in the establishment period, when you're first establishing the garden in that first, we'll call it, say you planted in the spring, in that first 4 months, when you trying to make it to September, October, you need to water it every day. It does require a bit of water, but once everything is established, you can wean that back to a more regular growing schedule. Because the most important thing is just getting everything through that first summer. Summer is already really stressful for plants, and a lot of new plants we have a planting window. Well, two of them. One of them, it starts in the spring from March 15th until June 15th. We'll target our spring planting. And then we actually don't plant in between June 15th and September 15th because it's just really hot, especially in DC. It's very hot and humid and stinky. So it's just not beneficial. It's a very stressful time for plants. So we usually try and stay outside of those windows, and then the cooler temperatures allow them to establish. But definitely in that first establishment period, you certainly need to water them a lot because it's so hot, and the media is thin, especially in those extensive green roofs we were talking about, under 6 inches.
Quick question here from me. So we are a bit fond of planting in the fall, but that's really in the garden, not on the rooftop. So is that different here? Like when we are talking about rooftop gardens, is it a bit different there? Like fall not being that good of a time for plant establishment?
Yeah, DC is we are a little bit nicer in the fall. It stays warm, like almost to Halloween. But I would imagine in New York, like our fall planting window, you'd probably want to avoid like after November 1st, maybe November 15th if you wanted to push it. The real metric is no planting after first frost, but I get a little squirrely and worried if I plant something and then it frosts in like 3 weeks, it could still really damage the plant. So I think to be safe, you're probably looking at like nothing after November 1st.
Thank you. And then I have a question from Deborah. She asks, what about roof maintenance? Does it have issues for leaking or roots growing through the barriers?
So the roots definitely don't grow through the barriers. And that's a reason why there's so many of those different layers of synthetic material before you get to the green roof. It's to ensure that for sure no roots are going to make it down and cause any leaking issues. And actually, there's a lot of data coming out about it now that we're getting into like 10, 15, 20 years, people are starting to understand the longevity benefits of green roofs. they've really been shown to actually increase the life cycle, or the expected life expectancy, that's the word, of a roof. A roof's biggest enemy is sun. It is breaking down, it breaks down everything. It breaks down asphalt, it breaks down colors. It just is, it is the biggest enemy to rooftops. So when you cover it with a green roof, it's protecting the roof from that sun. So the only time there is a failure in a green roof is during an installation failure, and that's somebody who punctures any of these layers without realizing it, and then later down the line a leak inside the building develops, and it's unfortunate, but you have to then track it and find where it's coming from on the green roof, and rip the whole green roof up, repair it, put it back. But yeah, the green roofs are actually super beneficial for roofs, as long as you work really diligently to ensure that they are installed correctly.
Thank you. And a quick follow-up to that question, like not necessarily that question, but what we are talking about here is really flat roofs, right? Not the slope or slanted roof.
Yeah, you can do them on sloped roofs. There's a lot more complexity to it, especially in the establishment period. Similar to like a hillside erosion, until once plants are rooted in, they actually can they can, they'll just be happy and the roots will hold all the soil in place. But it's getting to that establishment period that's really the difficult part. Before then, any kind of rain event stuff can really erode out. And they're almost designed, when you see on houses that have the little picks for snow, they're designed in sort of that thing. And they also have these really ugly but sometimes helpful, it it's like a big screw with a cap on it. I forget the technical name because I haven't done a sloped one yet. But it has the female piece of the screw underneath the soil with a big rod coming out of it, and then the cap screws down on the top, and you can space them. Say you're doing a planting with like 15-inch spacing on center between all the plants, you can put these little caps in between the plants, and it helps hold the soil wherever there isn't a plant. So that's kind of one way they do that. But yeah, again, it's way more complex.
But doable, but complex. Yeah. Wonderful. Thank you. And then Stephanie asks, would this work in a regular house roof or is the slope too much? Pretty much what you just said.
Yeah,
Yes.
yeah. I mean, the biggest limiting factor though for like a regular residential single family house is structural load. If you have a structural engineer, if you're interested in a green roof, you have a structural engineer come out, they can tell you what load your house is designed for and whether or not you're capable of doing it. And if you are, it's beneficial for all those reasons. But the sloped roofs are certainly difficult because the peak is substantial.
Don't see any other questions. Uh, it's 8:06. We are kind of close to wrapping up then. Dan, thank you so much. That was a very unique presentation, something, yeah, that was a great presentation and a lot of information. Um, and thank you everyone for joining us for this webinar. We'll see you for the next one. Please be there, and thank you again, Dan. Can't thank you enough. Welcome to Long Island and hope to see you around.
Yeah, no, thank you guys. Appreciate it. And thanks everyone for sitting in and listening to me. Appreciate it.